Hey, yeah, as said, I'm Tim Ruffles. So today I'm going to be talking about D3. D3, the data visualization framework, and why it's going to help you make your designer happy. So why does D3 exist? Well, I think D3 exists mostly because most charts are boring. Most of the data visualizations you see on the web are pretty prosaic. You know, there's a line graph, a few bars, maybe a couple of colors. No animation, nothing that exciting. Now, this isn't for the lack of trying. You know, the designers out there, all desperately trying to get to the top of Dribble. You know, they're working, they're slaving away to build some cool animated graphs, looking incredible, looking like this. So one day, you know, the designer comes to you, they show you this, and they're like, oh, it's going to be incredible. You know, when the data changes, it's all going to ripple and change and flex, and the users are going to gasp. And you're like, wow, I'm getting quite excited about this. You know, the project manager gets excited about this. Everybody in the company is getting excited about this, this product, this amazing visualization that you're going to be producing. Then you talk to the project manager, you're like, right, let's get this done. How long have I got? How many days to get this masterpiece complete? And they're like, for you, one day. And you're like, brilliant, okay. I'll just pop over to Google and I'll whack in charting library. And you jump on your computer and you hack away, and after a day, you go to the designer and you say, it's done. And they're like, wow, I can't wait to see it. All that hard work, tuning my, PSDs, working out how the animations are going to work. Let me see this in action. And you're like, come over here. You unveil your screen. Boom. There's some disappointment. Something's gone wrong between their hard work, your hard work, and this is what's come out. You know, you got your, unnamed charting library. You did everything you could to make it match reality, but didn't quite work. This is the sad result. Now, why does this happen? You know, it's not for lack of talent on either side, nor application. Well, I think it's because charting libraries are, by definition, very rigid. They have some really serious problems to solve. They're trying to do everything for everybody. They have to do everything via the wonderful world of option objects that you pass in. And I've seen some option objects that go on for pages. These things are monsters. And all those different options can interact with each other in various undefined and exciting ways. And your programming life effectively becomes beating yourself in the head with a load of documentation, trying to make these option objects do what you want. Not fun. Not very creative. When I think of doing data visualization, I'm expecting fun, enjoyment, creativity. Never my experience with charting libraries. Now, D3 I think is different. I'm going to rerun that story with D3. So, your designer works away, builds something incredible, puts it onto Dribble, gets many bounces, many rebounds, it's looking good. It's on the front page. Cool. They come to you. They show you all these mock-ups with their various, exciting transitions, and they wait for your reaction. You fix them in the eye and you say, lacks ambition. It's 2014. You patronize them a little. You're like, the web is an interactive medium. What are we doing here? Where are the animations? Where are the transitions? This is too subtle. No one's going to understand what's going on. And they're like, well, how many animations do you want? And you're like, gratuitous amounts of animations. That's how many animations I want. I want the kind of visualization that when someone is at work and they open up, their daily report, they're like, oh, how many clicks have I got on my website? And they're like, boom! Bloody hell, what's going on here? Other people in the office, they see something on their screen. They come over amazed. Maybe they get their iPhones out, they take selfies of themselves with your visualization. This is big. Maybe someone's brought their kid into the office. The kid glances at it. For a moment, a little smile plays across its face, and then it just spontaneously starts crying. That's how much animation you really want in your visualizations these days. So, I think I've done the traditional thing of massively overselling the tool. Why is it so good? Well, I'm going to highlight 3 things through the means of speech and probably risky live coding. And these 3 big ideas are as follows. First big idea. D3 is grassroots charting. It's a set of primitives from which you build up your visualizations. Rather than having a whole pre-rolled chart for you to chuck options objects into, you're going to be taking all of the control on the rendering, the data munging, everything. You get all the control. Power to you, power to your design and your designer. You're going to be building up from the bottom, rolling around. Good news. Also, no proprietary APIs. It's a very thin wrapper over the DOM APIs you know and love. Your HTML, CSS, and SVG, it's all there. It's all usable. If it gets extended, D3 is not going to need to be updated. You can just whack in the new properties. It's all very, very, very familiar. The data you want to chuck in, it's up to you. No enforced structure at all. You're going to be the one binding that data to the visualization so you can do whatever you want. Freedom. The first big idea of D3. Second big idea. D3 is extremely familiar. So by that I mean if you've already done a ton of DOM programming, you know your attributes and your tag names and all the CSS spec off by heart, you're going to find a lot to like. If you know your jQuery, you're going to see it and you're going to understand it almost immediately. Because in both jQuery and D3, we select elements with a chaining API. We use functions to affect all of the selection at once. So rather than doing for loops and things, we just say, okay, I want to set all of these attributes on all of the selection at once. And then we can do the next thing, and we can set all of the styling tags and blah, 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 blah. So very, very familiar. So, mouse. If we had a look at this example over here, you can see we have a div. Inside that div, we have the word hi, and then we have two links to jQuery and MDN. And we thought, don't really like that blue. I want to sort that out. You would, in either D3 or jQuery, go and grab a selection. So let's say we go and grab familiar. And then we can grab those anchor tags inside. And in this case, let's go and set the style color to red. Oh, not so good. Can I spell? Familiar. I'm just going to copy and paste this. Hey! Exciting. So you can see, not so different. In jQuery, it might be .css instead of .style, but you can see this is all, the DOM APIs you know and love, nothing very complicated. Chaining, selections, simple. So D3 is very much a bring your own knowledge. And everything you learn with D3 is going to be applicable when D3 is long gone and the newest, coolest data visualization library comes along. You're not learning like a wrapper over SVG like you would with Raphael that adds group elements that don't work quite the same way as SVG group elements. Everything is just the DOM, which is cool. So, like I say, if you start learning some of the DOM APIs through D3, you start learning some SVG, you can use that in the future any way you like. And D3 is incredibly SVG native. It's very, very easy to use SVG in exactly the same way that you'd be using HTML. So if we wanted to go and grab this SVG and stick a circle in the middle, wouldn't be so hard. We'd have to go and select that element, so SVG. Let's use the ID. And we would append ourselves a circle. See, nothing special, no namespaces required for SVG. And then let's set up some attributes. So attributes in the circle would be the CX for center X, CUI for center Y, and we want to set the radius at the same time. So that's 100 as well. Damn. SVG, append circle. What's that, sorry? Bing! Thank you very much. Very, very hawk-eyed people in here. So we have a circle. Very simple. There's the same kind of code would append a div and set some attributes. We've done exactly the same thing with SVG. So you can see, nice and simple. Interactivity. Again, exactly as you'd expect. If I want to go and grab a DOM node, select clicky, and I want to make it do something on a click. Chuck in a function. Let's do something simple. Clicked. I really can't spell today. Bang. Excellent. So, hopefully I've shown you that, picking up this bit of the D3 API is not going to tax you very much. Hopefully it should be extremely familiar to you. So what's different about D3? Well, where jQuery's API is focused on the DOM and manipulating DOM elements, D3's API is as much about data and the relationship between your data and your elements. That's the big idea, data-driven documents. Data, document. The intersection of those two things would be D3. And really, it's just one callback that turns jQuery into D3, in my opinion. Just understanding, one concept, which is, whereas we'd have let's say, a jQuery callback, it's normally going to be, index, and this is going to be the current element, and we're going to do all our stuff around that. In D3, rather than manipulating the elements stuff directly, we'd normally be using the data that corresponds to an element to return the attribute's value. So in this example over here, let's say we select a load of bars. You can see we have got the data for element as the first argument. We have the index of the data item in our array, and we're going to return the background we want for each of those elements in turn. So if we had 100 bars, that callback is going to be called 100 times, with each of the bars in turn. The return value is going to be the background color for that corresponding bar. So this API is kind of important. So the first argument is going to be the data for an element, and the second argument is going to be the index of the data in our data. So you can see that together they're going to be able to handle pretty much anything we can throw at it. The data is going to be holding all the attributes we want to represent on the screen. We can turn an age into a size, or someone's income into an X value, whatever. And then the index is going to allow us to do things based on the position of the data in maybe a sorted set of data. And this is going to be the bridge between our elements and our data. This one callback. So, wherever you'd be setting static stuff in jQuery or directly manipulating an element, you're going to be using one of these D3 callbacks to get the attributes. Big mystery though, where does this data come from? We can see we're calling these things and using the data items, but where does it come from? Well, whenever we have a D3 selection, there's a method on it called data, which imaginatively binds the data to some selection. And it's this relationship between data and elements that's kind of the core of understanding how to do D3 programming. We basically will always want to be synchronizing the state of the data with the state of our screen. If new data arrives, we want to add new elements. If the data changes, we want to update the elements on the screen. And if the data gets smaller, we want to delete some of those elements. So we've synchronized the state. So we're going to be driving the document with our data. So, that's a bit weird. In this example over here, let's go and grab these. Drive me. Cool, we've got some elements. And then we're going to call data. And why don't we make some things over here for our first item of data, and the second one would be London. We're going to call update. Sorry, not update. We're going to call text. So we're going to be setting the text content of these nodes. And we take the data item, we return d.title. Super. So you can see, we have selected two elements, h3, h3. We have then bound two items of data to that selection. We then call text to synchronize the two. So if the data's changed, it's now going to be reflected in the text we have displayed on the screen. Cool. Now, how do we decide which element to associate with which item of data? Well, the idea is a key function. So whenever we call data, we can also pass it a second argument, which is the key function. And again, it's very simple. It takes the D3 callback, a function with data and index, and returns something. Now, by default, it will just return index. So you can see the first element bound to the first item of data, second element, second item of data. Pretty predictable. If we want to do something sorted, then we can just use whatever ID we have in our data set. So whatever, return data.id. And this is vital for animation. If you think about what we need to do in an animation, we need to have the same piece of data displayed and then manipulate some of its attributes. So it either moves around the screen, grows bigger, grows smaller, but we certainly need to keep the same data in the same element. So if we have this example over here, let's say we're comparing different data visualization libraries, and we want to see, okay, well, what's the best one for SVG? Oh, it looks like D3 is pretty good. What about working with data? Yeah, still D3. And using existing APIs, still D3. So you can see the same element needs to be bound to the same data set, and then we just manipulate one of its attributes, in this case, the offset of the top of the element, and then CSS3 transitions take control of the rest, and we get that nice, smooth animation. Cool. Alrighty, we got here number 3. Now, visualization can get tricky. So D3 has a very nice unifying metaphor for what a visualization is. And it's the visualization is theater. So in the theater, we have a stage, and the data can either enter the stage. So let's say we've just done our first load of the data, we've done an AJAX request, or we have some kind of real-time API with WebSockets or event source. You know, a new price tick just came in, we need to put on our pricing graph. You know, or a player just appears on the high school table and knocks someone else off. So it enters the screen, we need to represent that to the user. We need to animate it on or whatever. It's the first context. Second one is once they're on the stage, they need to act. You know, what's happening with this piece of data? You know, maybe the price changes or the Reddit story is being voted up or down. We need to visualize that too, and that's the update. We're updating an existing thing on the stage, it's doing some interesting stuff. And then finally, its day is done, and it needs to get off the stage. We can exit it, and we can control that too. So with those 3, if you think about it, we've covered all the possibilities for our data. We know how to get it on the stage in a nice way. We know how to update it when it changes. We know how to get it off the stage, again, in some nice animated fashion. And these are referred to in D3 as the contexts. We've got 3 contexts of our selections. They're either an enter context, an update context, or an exit context. And this is the kind of basic life cycle of a D3 visualization. We make a selection, some nodes. If there are fewer nodes than we have data items, we need to get some on the screen, so we need to create new elements in the enter context. If we have some existing elements bound to data already, and the data's changed, we need to update them. And if we need to get any elements off the stage, because the data is no longer needing to be visualized, we will use exit. So if we want to do some enter, we, let's say, have our add target. So grab add target, bind some unexciting data to it, 1, 2, 3. Oh, we want to do select all paragraphs. We're going to call enter to control how the data that's all lonely and doesn't have an element of its own gets on the stage, and then we're going to append a paragraph tag for each one. And we're going to say, okay, text. And we're just going to say return D. Super. So once again, we have selected the place we want to add the things. We have selected, this is a kind of interesting one, all existing paragraph tags within that div. You might say, well, there are none. Then I would say, there are none. You're quite right. We have then bound data to that selection. We call enter, which is controlling when we have data, but no element. And then every time in the enter context we have this data, but no element, we append a paragraph tag, and we set its text. So that's where we get data on the stage. Good news. So enter will very, very commonly be followed by an append. You can do whatever you want in these contexts. There's no kind of magic in them. You do completely the reverse of what they sound like. But normally it's going to be followed by an append. Now update. Let's say we have some existing paragraph tags on the page. So we go D3 select update. We select all paragraph tags. This time we have a selection with some elements in. We then bind our data to it. Photo London. And we do exactly the same. I really should just define this as a function. We're in the update context straight away, so we're just going to update that data. So the existing elements we found, those 2 nodes, have been bound to those 2 items of data. Like I said, the default key function that decides which item, the element gets which data item is just the position in the corresponding selections. So you can see the first item of data gets bound to the first element, and we update it. And like I said, after we're done. Yeah, update. The update context is kind of implicit, which is maybe a little bit unpleasant. So when you've done the .data, we have got back the update context. We don't have to call .enter or .exit like with the other two contexts. Super duper. And then finally, exit. So you can pretty much imagine what's going on over here. So if we go D3 select exit, select all paragraph tag, and we bind just a single item of data to it, we call exit and we call remove, we should see that final item gone. You can see I can run this as many times as I like. Because like I was saying, what D3 is doing is a synchronization between two things, the state of your data and the state of your visualization. So if you're saying, every time something needs to leave, leave, and there's nothing needs to leave, nothing leaves. So it's a synchronization. You can call it as many times as you want. It's very declarative, rather than imperative, like finding the items to delete them. We just say, when things are leaving, you want to do this. So exit is the context where we have more elements than data. We're syncing the data with our visualization. So here's a little visualization that explains these three contexts: enter, update, and exit. Here's the state of the selection. We have 2 elements here, but we have 4 items of data. So you can see the enter context has 2 things inside it. If we call append, we're going to see 2 paragraph tags appear. The more elements we have, the smaller the enter context is going to get, which is cool. Until if we have so many elements, we don't have data for them, you can see the exit context grows. If we go the other way, and we have fewer items of data than we have elements, we also see the exit context goes. And you can see that the enter and exit have a kind of mutually exclusive relationship. One of them is going to be empty, and one of them might have some elements. But you can never have elements in both. It's a kind of a nice way of playing around and seeing what's going on. Cool. So your standard D3 visualization is going to look something like this. You'll have a visualize function that maybe takes the root element in your data. You are going to select up your root element, select any existing elements you put on the screen, bind the data to them, handle entering, handle exits. You're done. And as I said, this is a function that can be called as much as you like. So anytime the new data comes in, call this function again and again and again and again, and it will keep it synchronized. We'll use transitions and delays and all that kind of cool stuff to make it a little bit more exciting. Okay, we have seen enough of D3's API. Now I think I need to poke the demo gods in the eye a bit harder, and I want to try and rebuild this visualization of Reddit data in a live-coded fashion. We will see. So this is a visualization of a threaded conversation on Reddit. If you are not aware of the wonderful world of Reddit, it looks like this. So here is a Reddit subreddit of D3 conversations. And the reason I use Reddit so often for examples is they have one of the best APIs in the world. If I'm on a Reddit URL and I want to find the data in that URL, I go over and type .json, and JSON appears. That is how you write an API. I like this. No documentation required. You can see this data is kind of I'm sure they have good reasons for it. It's a little bit messy. We probably want to clean this up a bit. That's not very exciting for live coded, so I'm gonna leave that done already. But you can see we've got data. Inside we have children data, and we have replies somewhere down inside here. So we have lots and lots of interesting data to play with. If we go back to the, you can see it's a threaded thing, so we have comments. Comments can have comments, so it's a really, really good kind of use case for a hierarchical visualization like this guy. Now this is using what's called a layout in D3, and layouts are about as close to a kind of pre-build as you're going to get in D3. But what they actually do is just handle all of the algorithmic side of a visualization like this. They do no drawing on the screen for you. All they do is they take your data set and they transform it into a slightly modified data set, which has all the calculations done to lay it out like this. Now, the flexibility this gives you over an actual layout that just draws stuff to the screen is huge. So if you imagine something like a histogram that takes, say, a set of 10,000 items and gives you back a set of 10 bars in your histogram, all it's going to give you is the X and Y position of the bar and how wide it is. And then you can interpret those things however you like. if you wanted to, you could interpret them as, Cartesian, whatever the word is, polar coordinates, and wrap your histogram around a circle, or some kind of crazy 3D visualization, or whatever you like. So just doing the data side of it for you and leaving the visualization up to you gives you huge flexibility. Alrighty then. Okay, so let's go piss off some demigods. So we're going to be starting with this lovely white screen, which is a bit terrifying. And I'm going to mirror up my display so I can see what I'm doing. Okay. Alrighty. Okay, so this is our visualizations markup. You can see just a little bit of styling, and you can see just a tiny bit of HTML to get us going. We have an SVG with a set width and height. We're loading in D3, and we're loading in our rebuild. Now, this is going to be defining a public API of exactly one function, which is called Reddit pack. So this is a visualization that visualizes some subreddits threads. So you can see I've chosen where to attach it, and I've given it some initial kind of data sources. I want you to load these three URLs, load in the data, and I want you to visualize them. Now, if you have a look at the rebuild, you can see, okay, we've got a main function. And the main function is the one we're exposing as an API to the window, so other people can get at it. And the main function takes an element to actually visualize in, the list of stories, those URLs, and an index, because we're going to be recursively calling this main function so it can keep visualizing a whole list of different threads. So you can see it kicks off, just this will grab the next story, we'll just keep incrementing index, modulate the list of the stories. Every time we do that, we go and load in the story via Ajax, clear the loading if there is any loading, and we do the visualization. And you can see it just calls itself forever and ever and ever. Now, the actual visualization function is where it gets interesting. So we go grab the SVG, and then we are going to do a number of things. First off, we want to calculate how big is our visualization. Now, this is pretty easy. I'm just going to go and grab max, and we're going to choose, okay, is it wider or is it taller? We want to fit inside. No, actually, we want to fit inside the smallest, don't we? SVG, right. Cool. So we're going to be fitting inside the smaller dimension of that SVG, so we don't blob out the sides and look rubbish. Now, the layout is going to be a little bit more complicated, so I'm going to leave that till last. I'm just going to get some example data on the screen. So we're going to have a load of nodes, which are those circles. We want to get them on the screen, and we're going to set a bunch of kind of bits and pieces on them. We need to position the circles. We need to size the circles. And we also want to set some classes on them in case they're a leaf node. Because you may have noticed that if we are a leaf node, we go orange. Cursors. So those ones, the orange ones, are leaf nodes. They have no replies of their own, so I've just highlighted them with a different color. And you can get the kind of basic idea of this story. You can see, okay, there's one very popular comment that spawned an entire conversation, whereas this one is mostly just single replies with no replies of their own, so they're pretty uninteresting. It gives you a kind of a vague sense of what the conversation is doing. Righty. So let's just get some circles on the screen, as it's a bit scary seeing nothing at all. So what I'm going to do is I'm going to go, okay, SVG, I want you to select all story. I'm going to just bind some example data, whatever, 20, 50, 100, 15. So these are going to be radiuses, just for the example. Nice and simple. Now, for each of these stories, I'm going to first off append a group. And a group in SVG is very useful as it allows you to translate an entire group of nodes in a nice simple way via the transform property. So I'm going to say, okay, nodes, enter. So all of the current nodes that don't have a story element of their own. I'm going to append a group element, which I'm then going to class story. And then inside I'm going to append a circle, which is cool. So we should have some circles on the screen, but obviously they're not going to be very interesting unless they have some attributes. They're just going to be blank circles sitting there, invisible to our eyes. Now, there's an interesting trick in D3, which is very often you're going to be wanting to do the same thing whether a new node has just been inserted into the DOM or it's been around for a while. And there's a magical update and enter context, which appears after you've called enter. Very implicit coding, violates the kind of normal rule that implicit is much worse than explicit. Explicit is good, and then people can understand. So I normally put in a comment, update and enter. So these are nodes that are already there or nodes that are entering the screen. So I'm going to say nodes. Now what we want to do is we want to say, okay, I'm going to set the, first off I'm going to transition. Transition just means any of the numeric changes I make to those attributes are going to be happening over time. Then I'm going to say, okay, I want to set the translate. And we can just make up some stuff over here. Sorry, transform. And I'm going to be setting this to translate. We'll just do something simple. Let's just move them along the x-axis times whatever, 100. And we'll leave them all at, say, 100 in the y-axis. Kind of simple. And then we want to select that circle we've appended to each one of those, and we want to set its radius. Otherwise, we're not going to see them at all. Oh, no, we want to make that data. So it's a bit more interesting. Cool. So I'm going to return data, because I think I've just appended numbers. So, yeah, we've selected the SVG, we selected any existing stories, and we've bound data to them. The new stories entering the screen will have a group appended, class story, and we're going to append a circle within that group. And then for both nodes that are updating and nodes that are entering, we're going to transition. We're going to set their transform translate property, so they're going to be moved on the x and y axis. We're going to select the circle and set the radius. So hopefully, we should see, brilliant, circles. So we have moved beyond the scary white screen of death. We have some circles on the screen, but they're not related to our data. Now, if you remember rightly, this is a fairly kind of complicated looking beast of a visualization, and we're going to be using this D3 layout pack to handle most of the heavy lifting for us in terms of actually doing those calculations. So a D3 layout is actually just a function you configure in various ways, and then you're going to chuck it, and it's going to provide your data for you. So I'm going to say d3.layout.pack, so I get myself a new layout. I'm then going to set the size of this layout, so it's going to be diameter in both directions, so it's a circle. And then we're going to set, okay, how big are each of these nodes? Well, in this case, with our real data, it's actually going to be the length of the comment itself. I'm going to say, how do you get down the hierarchy? How do you get the children of that node? So I say children, and that's just going to be d.replies. Okay, cool. So we have a layout ready and waiting. We can use this function to create our data. So we have the raw data coming in that looks like this. It's a tree structure of nodes like that. Replies is an array of these nodes, and all the node has is a body apart from the replies. So over here we have D3. Now what I'm going to do is I'm going to say I want to bind the root of our data, because this is kind of a single node thing, data root over there. And rather than setting the data like that, I'm going to use a D3 callback. So just like we can use a callback to set attributes, we can use a callback to set data. And what I'm going to do is it takes the single element over here, data root, it takes our layout, so layout over here, and it will create nodes out of that data. So D3 layout pack, size, value, children. We've chucked in the root node of our tree, and we've used D3 layouts and nodes to create all of the different story elements we're going to need. Now hopefully we should just see lots more circles. Oh no. Oh, that's fine. So down here where we've got radius, at the moment we're just using the data node, which was fine when it was a number. Not good now, so we'll just try with tens. Cool, lots of circles. Some progress. What if we use data.radius? The layout should have created a radius for each one of our circles based on that, the length of the reply. Ooh. Circles are different sizes. It's getting exciting. You can see the transitioning is already working when the new stories get loaded. It's looking pretty cool. That looks cool. And the next thing we want to do is to set the x and the y from our layout. Aha! Much nicer. So there you go. We have created many, many nodes. We're using the attributes on the circles to kind of draw the correct radius size. We're using the attributes on the groups to move them around correctly. And you can see that D3 has done all the very heavy lifting of working out how to fill this space with this recursive tree structure. Now, the last little tweak I have is to highlight those leaf nodes, so it's very obvious which comments are kind of uninteresting. And if we see lots of leaves at the immediate replies to the parent, we can see lots of people are being unimaginative with their comments, and they're trolling, and they're not promoting much debate. So let's pop that in as well. So classed leaf takes the data in index, and all we're going to do is return what's a leaf node. It's something with no children. That's all we need to do. Brilliant. So we have recreated our visualization in hopefully what seems like not very long. You can see it's nicely transitioning between states. All the circles are changing sizes and moving around, and everything looks hopefully pretty cool. Fun, 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 fun. Okay. I've got this on both screens, so I'm going to demirror. Good news. Okay, so the demo gods were very kind today. The demo pretty much worked. Whew. Good news. So, to sum up, my 3 big ideas about why D3 is so awesome and should be the death of all boring charts and the start of a bright new relationship between you and your designer are, it's grassroots data. It's power to you and not to your charting library. You've got primitives to build up your widgets in any wonderful fashion that you see fit. My thing working? It's very familiar. You've basically got all the knowledge you need to get started. Everything, the hours you've poured into learning the DOM APIs and jQuery are going to repay you dividends when you start using D3, which is pretty wonderful news. And finally, it's this idea, this very central and useful metaphor as visualization as theater, that you either need to work out how your data gets on the stage, what it does when it's acting upon the stage, and when it finally needs to go and bugger off, how to get it off the stage in a nice and exciting way. So, thanks a lot. Freedom from rubbish charts.